Okay. Okay, so this is the last part. Last part of chapter 2 is 2.5, buoyancy and stability. Okay, but today the first class today we will cover buoyancy first, and tomorrow your second class we will cover stability. Yeah. Alright. So okay, sorry. Okay. Alright. So buoyancy. For today's class about buoyancy is very easy. Very straightforward, very sangat senang lah, tak banyak benda kan, sangat basic, and when you just learn about this you will easily understand compared to the one that before that we learned about the hydrostatic force in plane or curve. That is much more complicated, that is much more a lot of things. So if you master that, and buoyancy I think is just like a cake, like peanut for you. Okay, so buoyancy, I think everyone knows about the meaning of buoyancy. The buoy and ship are obviously designed to float. Consider any kind of boat, raft or other floating object that is expected to maintain a particular orientation when placed in a fluid. So terapung lah, daya apung. So a body in a fluid, whether floating or submerged, terapung or tenggelam, is buoyed up by a force equal to the weight of the fluid displaced, which is the Archimedes principle. I think we learned this principle during secondary school. Ada belajar ke sebelum dengar? I think so. Have you learned?
Ada.
Ada sir.
Ada. So we've learned that before. Archimedes, very basic principle. Anything, any object, whenever it's submerged in a fluid, the weight of the displaced fluid is equal to the weight of this submerged body lah. So if this body submerged is whatever Newton, it will be the same, the one with the fluid displaced. Okay, so that's the basic Archimedes principle lah, because we will using this principle in buoyancy. Alright. So buoyancy, buoyant force, so FB, okay. The upward force, a fluid at Z, okay, a fluid at Z on a body immersed in the fluid lah. So this is in the fluid, okay. So there will be saya dah ada pen dah sekarang, pen baru sampai. So my writing will be nice. I read a lot of the feedback from your feedback through the feedback form. My handwriting is very very not clear, unclear, very buruk. So that's because I'm using a mouse. So now I have a pen. So hopefully my handwriting is nice. Okay, so you have so this is your FB line akan bertindak ke atas. Okay. So a flat place of uniform thickness H submerged in a liquid parallel to the free surface. So this is the surface of the water. So they are immersed in the fluid. So the buoyant force FB, okay, which is acted at the bottom of this object, right, is equal to the force at the bottom minus the force at the top. Okay, the net force lah. So the net force of this will give you the buoyant force, daya apung. Okay, so how you the formula is, so for the force at the bottom, okay, you know the rho GV, and you know rho GV term before, right? So this rho GV can also be writing by rho GAH, because you know the volume is AH, the area of the surface, times the height, so that will give you the volume as well. So at the bottom, you know the height is S plus H, okay, the height of this object. So you have rho of the fluid, because it's the bottom, so it's totally immersed in the fluid. So you have this rho of the fluid, whatever fluid, water, mercury or anything, times G, the gravitational force, constant, times the H, which is the S plus H, because it's at the bottom, times A, minus this upward force, which is going downwards. Okay, this is rho g ah as well lah. So but the h now is only s because it's only here. Okay, so minus this will give you the net force, which is the buoyant force. If you see from the formula, you can cancel out. Because this ada s dengan s, so it will cancel out. So we leave to you only rho g h a, and this can give translate as well in rho g v lah. Okay, it's very easy. Rho g v je, buoyant force rho g v. You need to know what volume in the immersed fluid. Kan? Alright. So Chamberlain's principle, you also have learned about this during your secondary school. The buoyant force acting on a body immersed in the fluid is equal to the weight of the fluid displaced, okay, by the body, and it acts upward through the centroid of the displaced volume. Alright, so there are component of the weight of the object, okay, and there are the buoyant force, which is equivalent to the weight of the fluid displaced by the body. So you can have, there are two component, W and buoyant force. Okay, so it's very easy. If the W is bigger than your buoyant force, okay, that means, okay, if your weight is bigger than your buoyant force, that means the object will sink to the floor of the liquid lah, of the tank. If your W is lower than your buoyant force, that means your object will not sink. It maybe float or maybe neutrally float here, will not sink. Alright. Okay. So we know the buoyant force will equal to W. Okay. So for floating bodies, the weight of the entire body must be equal to the buoyant force, okay, because it's floating. So there are three different scenarios. One is floating. Two is suspended body, which is neutrally buoyant. So they are not floating, but it is not sink, but still immersed in the fluid. Okay. And the last one is a sinking body. So whenever the object, the rho of the object is less than the rho of the fluid, it will float. That's a very basic understanding. And the object, the rho is very lower than the fluid, it will float. If the rho of the object and the rho of the fluid is similar, so it will not be floating, but it will not be sinking. So it's neutrally buoyant, still inside the fluid. Okay, totally immersed in the fluid. But and the last one, if the rho of your object is bigger than the rho of fluid, that means your object is very heavy, and it will sink to the floor of this tank lah, anything lah, tank or reservoir or whatever. Okay, so these are three different scenarios lah. Okay, so for floating bodies, okay, the weight of the entire body, this entire body, must be equal to the buoyant force, the buoyant force FB. So the weight, weight bertindak ke bawah, okay, which is the weight of the fluid whose volume is equal to the volume of the submerged portion. The volume ni, okay, submerged portion of the floating body. So that's why you have this equation, which is the rho of the fluid, and ni FB ni term, okay, kat bawah ni. So the rho of the fluid times G times the volume of this submerged body, okay, and yang ni je, bawah ni je, is equal to the rho of the body, average body of this body object, times G times the total volume of this object. Okay, because it's floating, so the FB is equal to W. So it will give you this equation, and if you rearrange this, you can arrange lah. Okay, the rho, the volume of the submerged divided by the volume of the total object will give you is equal to the rho of the body divided by the rho of the fluid. Okay, so this is helpful lah whenever you want to solve any question. You must remember this lah. Okay, easily understand, easily understood. Okay, because FV equal to W, and you know this rho GV. Okay, so that's the theory. Very basic, very simple. Very tak ada macam-macam komponen apa, horizontal ke, vertical ke. It's just a different scenario, whether it's floating, whether it's neutrally buoyant in the fluid, or is sinking body. So that's only so that's the theory lah for buoyancy. So any question, anything that you want to ask before we go to the example? Tak ada? Ada?
Tak ada.
Tak ada? Alright. I hope you understand. I think it's very easy. Okay, so let's see example. Okay, this example. The weight loss of an object in sea water. A crane is used to lower weight into the sea. Ada crane and you lower weight into the sea, which have the density of the sea is 1025 for an underwater construction project. Determine the tension in the rope. Okay, they ask you to determine the tension in the rope of the crane due to a rectangular 0.4 times 0.4 times 0.4 and 0.3 the cube kan. Okay, 0.3 anyway lah, sama ada panjang ke, tapi yang sampai dia lah. A concrete block which have a density of 2300, so you know the density. Yes,
0.3 ke 3 sir?
3, sorry.
Okay.
That means you give attention. It's good.
Dia panjang tinggi.
Okay, 3. Concrete block with density of, so density of the block is 2300. Okay, they give you two scenario. One, suspended in the air, and the B, second one, completely immersed in water. Okay, so there are two. One in the air. So this, like assume this air, tak ada apa. So ada crane yang akan angkat this concrete block. Okay, they want you to find this tension, and the B, okay, the concrete block is completely submerged in water. So this is another block, the same block. So you have to find the tension of the rope lah whenever it immersed in water. So this is a row of water. 1000 Okay, how we can solve this question? Okay, it's very easy. Okay, we see from this example. So this is for air. Okay, for air suspended in the air. Okay, you have your component, the weight component. Okay, acting downwards. Always acting downwards. The weight of the object, the concrete block, and you will have the tension of the rope, and it's acting upward. So this is the one that they ask you to find, to determine. Okay, you know from this summation of force in vertical direction is equal to 0. Alright, and if you write it like, if you take upward positive, so Fr minus W will be equal to 0, and that's why it gives you Fr is equal to W here. Alright, so you know how to find W is rho GV. Okay, and you have the V for the concrete block by just multiplying all the dimension, 0.4 times 0.4 times 3, they give you the volume. Okay, and you have the G is constant 9.81, and you have the rho of the object given to you in the question, which is 2300 N. Okay, so you have everything, so you can find and you can solve lah this question, and that's the rho GV rho 2300 times 9.81 times 0.48, and will give you 10.8 kilonewton. Ni dia dah change to kilonewton, that's why they divide by 1000, and it will give you 10.8 lah, 10.8 kilonewton for the first question. Determine the tension in the rope of the crane, okay, the FR. Okay, so you have solved your question, the first question, easily, very easy. The second one is still very easy. The difference is just this block is immersed in the water, and now whenever a concrete is immersed in the water, it will introduce other forces, which is the buoyant force, and this buoyant force, alright. So because they are in the water, they will have force to push it upwards, kan, the buoyant force, kan, daya apung, try to push against it. Okay, now they ask you to find the FR again, okay, the tension in the rope. So because you have another component of force, so now your summation of force in y direction still equal to 0. So if you take upward is positive, so now you have FB, okay, minus W in different direction, plus FR, okay, the similar direction, okay, is equal to 0. Alright, so if you rearrange this equation, your FB, no, you want to find FR, so you normally arrange with the one that you want to find. So FR equals to W minus FB. Okay, similar macam ni lah, sama sini. Okay, you have your W already, because you find it here from the first question. Now you need to find your FB. Okay, so FB again, you know from the formula, FB equal to rho of the fluid G times volume, and the rho of the fluid, they give you the rho of the fluid, which is 1025, because it's in the sea. Okay, and you have the G still 9.81, and you have the V, and because the similar concrete, similar volume. Alright, so you have 0. Fully submerged. The whole body, the whole object is fully submerged. The volume is the total volume of the object lah. Alright, 0.48. So you give you this value for your buoyant force, 4.8 kilonewton. And using your equation again to find FR, W minus buoyant force FB, your W is 10.8 minus 4.8, and will give you 6 kilonewton. And so that's how you answer lah this question. And tell me whether it's easy or difficult. Anyone?
Not bad, sir.
Not bad. You are really tawadu, not too proud. It's very easy, so simple. I think you can easily understand and easily answer any question lah regarding buoyancy.
Sir,
Yes.
kalau yang soalan satu tu kan,
Okay, yang first.
kalau saya guna formula W equal to mg boleh juga ke, sir?
W equals to mg. M of the concrete,
Sebab density kan equal to m over v kan.
I know. So that means you
Soalan tak ada maths.
So they give you the density. So
Boleh
density
dapat maths.
equal mass over volume,
Density ada.
So you have density, you have the volume, so you find mass.
Kata saya kali dengan 9.81.
Can you try? You get the same answer?
Yes.
Then that means it's correct lah, because rho G ni sama dengan M rho G ke sama dengan rho V sama dengan M kan? Sama lah. Sama lah tanya.
Thank you, sir.
Alright. Okay, good, very good. Okay, so buoyancy material, ni only for your information, facts. So normally whenever we want to design or make any buoyancy material, normally people will with low specific weight and density, so not too heavy, not too so that they are not sinking. The density is lower than the fluid. Little or no tendency to absorb the fluid, so the material will not like baju lah kan, baju yang kalau kita baju biasa ni cotton will absorb the fluid and it will sink. So we normally do plastic or whatever lah which is not absorbed, and is compatible with the fluid. The material should be compatible with the fluid, whether the fluid is mercury or anything. So you must make sure the material is tak reaktif lah dengan the fluid, and its ability to be formed to appropriate shape, what shape you want, it can be formed, withstand fluid pressure, okay, because this have a buoyant force, the pressure, so it must be able to withstand, and abrasion resistant and damage tolerance. So that's, let me allow sekejap mana okay, like usual, and someone post the link so that they can fill up their attendance form. Okay, so this is, I think, not too important. I think we all know this. Okay, so I'll give this is another example. I think there are one. How many examples we have? 2, 3, and 4. Okay, there are 4 more examples. Maybe we can do it, so that we have a more understanding on this topic. Okay, a cube, 0.5 meter on a side. So a cube, that means all side is 0.5 lah. A cube, so 0.5, 0.5, 0.5. Okay. On the side is made of bronze, having a specific weight of 86.9 kilonewton. So they give you the specific weight, 86.9. Determine the magnitude and direction of the force required to hold the cube in equilibrium completely submerged in water and in mercury. So there are 2 different conditions, 2 different fluid, one water and one mercury, and they gave you the specific gravity of mercury is 13.54. So this is SGN. Okay, so one in a water, okay, or water, 2 in a mercury. Okay, go mercury. Oh, sorry. Okay, and it says here it's completely submerged. So you have to careful. It's completely submerged. So the whole body is under the fluid, inside the fluid, and it's equilibrium. So it's still there and it's not sinking lah, right? Okay, how we then they ask you to determine the magnitude and direction of the force, because kita ada satu weight of the concrete. It's a concrete, bronze, sorry. So we have another force upwards, the buoyant force, and we have another force, okay, because it's not floating, it's a completely submerged. So we'll have another force, okay, the external force, and we're not sure yet whether the force is acting upward or acting downward. So we're not sure yet. That's why they ask you to find the direction. You have to find the magnitude, the value, how many newton, and also the direction, whether it's go up or down. In both situations, okay, that's the question. You have to understand the question. Okay, let's see. Okay, this I think not really, you can read it later. Alright, so this is the first one. Okay, you have the block inside the water. Okay, you have this your FBD. Okay, always remember, draw your FBD so that you know what is your equation. You can write your equation correctly. Okay, so you have where's my pen? Okay, here. Okay, you have your FB going upward, and you have your weight going downward, and let's assume the FE is going up. So don't worry about which direction first, because you're gonna find it whether your assumption the FE is going up is correct or not by the value of your magnitude. Okay, so this case they assume it goes up. Okay, when you write your summation of force in vertical direction is equal to 0. So if you take vertical going up is positive, so you have FB plus FE, the external force, and minus W is equal to 0. Alright, so this is very easy, settle. And then you rearrange the equation because you want to find the FE. Okay, FE is equal to W minus FB. Okay, so that settle your second equation. So now you have to find the weight of the object and the buoyant force, and to find the FEN. Okay, sama juga macam tadi. So now you have they gave you the specific weight, specific weight. Alright, and they give you the volume. So from there you can find your weight, W, just multiplying by that. You have your V because the cube is 0.5 on all sides, so it's 0.5 cube. Will give you the V, the volume of the object, and multiplying by the specific weight, the 86.9, will give you the weight okay, the weight that goes down and acting downwards. This is 10.86. So that's settled for your W. But now you still need to find your buoyant force and the FB. Okay, so how you find your FB? Sama macam you find your weight. Alright, rho GV juga, and but so they gave you already the specific weight of the fluid. Okay, and you just multiplying by the volume will give you the buoyant force. Okay, so in this case the specific weight of the water is 9.81, and the displaced volume is equal because the object is fully submerged in the fluid, so the volume will be the same with the volume of the object, right? And so that's the displacement volume sama dengan displacement object because the object is totally under the fluid. Okay, so you now have your volume. Tadi berapa? 125. I think this typo 0.125. Okay, 0.125, so you're not confused. Okay, so now you have your FB so just multiplying by the specific weight of the fluid 9.81 times your volume 0.125 will give you this value 1.23 kilonewton because it already changed in kilonewton. So you can complete your equation to find the external force, which is W minus FB. You have written here. Okay, W is tadi awak dah cari tadi 10.86. Okay, minus 1.23 is equal to 9.63. Since this value is positive, bukan negatif, so that means your assumption, your FE is going upward is correct betul maksudnya. Okay, so the answer is the direction will go up, and the magnitude is 9.63 kilonewton. Okay, so that's your final answer. Okay, let me ask you from the question. Okay, this question, how you can know straight away whether the force should be upward or downward, the external force. This FE ni, so this is your when you solve this question, you just assume okay, wherever sama ada dia atas atau bawah. Let's say the magnitude is positive, then your assumption is correct. But if you find your magnitude is negative, that means your assumption is wrong, so it's downward end. Okay, but from the question, there is a clue. There is a clue that can help you to determine whether the magnitude, the direction is upward or downward. How you can tell me? How you can see that in your question?
Completely submerged kot, sir.
Completely submerged. It's a completely submerged, but it's never telling you whether the object the object is completely submerged. Okay, I know, understand. but you never know whether the force here needed to push the whether the force, the external force, need to push the object, or the force need to go up to make sure the object is submerged. So this is not telling you whether about that. There is another value that can tell you straight away whether the object needs an upward force or downward force to completely submerge. How you can tell me? How you can say that?
Force required to hold the cube in equilibrium.
Okay, I know that the force is required to hold. So the force required to hold. Okay, so whether it's hold downward or hold upward, it depends on some property. What is this property? Okay, let me give you a hint.
Bronze ke? Bukan
Apa?
Material
Okay, the material. Yeah, it's something about the material lah. So what is it?
Bronze. Kira bronze. Tak tahu.
No, it's a bronze. So what is the property of the bronze compared to the water?
Oh,
Apa yang besar, apa yang kurang?
Density.
Density kan?
Density bronze
And-
lagi.
yes.
Berdaya.
So, and you learn before in your secondary school or from your first time maybe. I think secondary school pun kita belajar. Anything in a fluid. Okay, let's say this is a fluid. Rho, katalah ni water water. So rho of water 1000 kan? 1000 kilogram per meter cube kan? So, any object which has the rho is lower than this, okay, 900 or whatever, it will float kan? So anything object that have larger than this,
Dia tenggelam.
dia akan tenggelam lah. Okay, in this question they give you the density of the bronze. You can find it from the specific weight. Okay, and specific weight sama dengan apa? Specific weight sama dengan rho g kan? Betul tak? Betul tak ini?
Betul sir.
Betul eh? So they give you the specific weight which is 86.9 kilonewton. Yeah, 86.9. And you can find your rho lah of this object kan by just divide by your g kan. 86.9 kilonewton, 86.9 bahagi 9.81. So this will give you the rho of the bronze is 8858 and kilo per meter cube. And this is larger than 1000 kan? So the rho of the bronze is larger than the rho of the fluid. So in natural position, if you throw the bronze, it will sink to the floor. Kan? Betul?
Betul.
So that means your external force to make it equilibrium completely submerged, where is your force? Should be acting. Huh? Faham tak ni?
Macam mana sih?
So where, tadi saya kata kalau awak letak bronze dalam air, dia akan jatuh lah kan? Dia akan sink. Tadi awak cakap tadi kan? Because the rho of the bronze is larger than the rho of the water, so the bronze will sink in the water lah. So in this question they said, what is the direction of the force required to hold the bronze in equilibrium completely submerged kat sini?
Outward sir.
Outward. Mestilah outward kan? Sebab dia dah berat sangat, dia akan jatuh. So your external force that need to apply on this bronze is acting outwards lah, so that it can stay equilibrium in the fully submerged position. That's what I think I said to you. From the question, you already know that direction of the force is whether downward or upward, with regarding using your density of the property lah, property of density kan. Density property ni for bronze and for fluid kan. Okay, let's say for the second question, the second condition in mercury. can anyone tell me whether it should be the direction of the force should be upward or downward?
Downward je.
Downward?
Upward.
Huh?
Upward juga.
Downward?
Upward.
Upward?
Mercury lagi.
Why?
Ah.
Why upward?
Upward.
Density mercury 1354.
Okay.
Oh.
1354 apa? Mercury sorry. Density of mercury
135.
sorry. Mercury, density of mercury is, you say 135.
4.
Is it 54 or 50? 40?
Oh, yes.
Huh?
40.
50 eh? So this is your density of mercury. Okay. Density of your bronze?
Density of bronze tadi berapa?
88 kan? 88
88.
9 katalah let's assume. Say, and you said the force is apa? I think downward
Upward.
Upward. Why?
Sebab dia nak equilibrium.
In natural position without the force, tell me whether the bronze is floating or sinking.
Dia submerge.
In natural
Sinking.
in natural position.
Natural
Ni awak bagi tahu lah ni property dia. So the
okay.
bronze is lower kan? 8,000
Yeah.
dengan 13,000 kan? So the bronze is lower than the bronze the property the density of mercury. So if your object is the density is lower,
Ya,
You float.
saya salah faham. Dia
Kiranya bronze,
Kalau kita letak dia
bronze tu terapung kat mercury lah.
okay, so where the force should be acting on the bronze to make sure it completely submerged? Downward lah kan?
Downward lah.
So it's different lah. Tadi dia upward tadi kan?
Saya ingat dia dalam air lagi.
Oh,
Sorry,
okay,
sorry.
okay. Well, Abi, you have given me this. Okay, so that's why I say from the property of the object and the fluid, you should already determine whether the force is upward or downward. But obviously, you still can do it by calculation. You still can assume first whether it's upward or downward, and when you calculate the value of the force, whether it's positive or negative, then it tells you whether your assumption is correct or wrong. Okay, let's answer the number B, the second question. Okay. Okay, we done that. Okay, so this is the bronze inside the mercury. Now it's a mercury. Okay, so you have to assume lah whether your Fe is upward or downward. So this is by using calculation. So you don't use the property of density to assume, to guess which direction is the force. You still can do by calculation. So now you have your summation of force, vertical. So you have this is for A, for A, Fb, okay, upward positive, plus your Fe minus W equal to 0, and for your second guess, okay, Fb minus Fe, because now your Fe you assume downward, okay, minus W equal to 0. So you have two different equation. Now the first one, Fe equal to W minus Fb. The second one is Fe equal to Fb minus W. Okay, now you can find the value lah. So your value for the weight of this block, of this bronze, you can find it from this equation. They provide you the specific weight of the bronze, which is 86.9. So you time V, the volume of the bronze, they gave you. So it give you 10.86 for the W. Okay. And for your Fb, ikut sama juga macam tadi. So they give you the specific weight of the mercury. So times V will give you the force, the buoyant force. Alright. So this is your buoyant force will equal to 16.6. Okay. Now when you put back in your equation, both equation for your first assumption, this is A, this is B. Okay. your first assumption where you assume that the external force is going upward, okay, this is upward. So Fe equal to W minus Fb, 10.86 minus 16.6 equal to minus 5.74. Okay, and your second assumption where you assume the Fe is going downward, so your Fe equal to 16 minus 10, it will give you 5.74. Sama, magnitude sama, but the direction is different, so this is positive. So because if this is negative, that means your assumption is wrong, your direction for this one is wrong, so it should be downward end. Sama macam you assume for this for B. So that means the direction is going downwards to push the bronze inside. So we need the force to push the bronze to completely submerge in the mercury. So you can do this. You have to do these steps whenever you want to answer the question. You can follow. You have to do. Not you can. It a must. You have to show your calculation, your step by step, how you determine the direction of the force using the value that you have calculated. But just for your it's a trick. You can always determine whether the force should be upward or downward by comparing the density of the object and the density of the fluid that they are immersed in. Okay, so that's how you do it lah. Alright. Okay, think. Okay, so that's it lah. Okay. Any question? Senang kan? Tak ada orang jawab. Senang.
Boleh lah sir.
Yeah. So we look in no, it's one. We look at another example. Okay, I have shown you two examples already. Okay, 1 and 2. So now I want you to do by your own lah. Okay, macam biasa, someone guide us to solve this question. Okay, anyone to volunteer today? Siapa? Siapa nak buat? Ada tak nak buat? Sorry. Okay, siapa nak buat ni? Soalan ni senang je ni. Tak ada nak buat kan? Hello? Anyone can hear me? Ada dengar kan?
Dengar sir.
Oh, ada. Okay. Okay, someone, anyone? Come on, anyone? Guide us how we can solve this question. Determine the height we submerge in the body, in the fluid. Okay. Tak ada ke nak buat? Ha? Oh, ni apa semua lapar ke ni? Tak ada Okay lah, saya buat lah dulu.
Tak ada.
Apa? Nak buat? Awak nak buat kan?
Saya pun tak tahu sir.
Tak tahu
Saya confused lagi.
Confuse lagi? Okay, it's okay. I try to explain it clearly or more clearly so that we can understand. Okay, a block is floating in water. So they said the block is floating in water. So this is, if you see from this note, it is the first scenario when the floating body. Okay, where your FB equal to W1. Okay.
Oh, sir, kiranya soalan ni maksudnya dia apa ni? Tenggelam separuh ya?
Dia floating. Dia floating maksudnya dia tengah separuh je kan. Floating ni bukanlah maksud floating tu apa totally
Tak habis.
macam tu kan.
Oh.
Dia still macam ni pun floating juga kan. So depends lah on the question. So this is, they said is floating but some part of the object is below the water, or some part of the object is atas water kan. So this is still considered floating kan ni kan. Kau assume dia tenggelam. Floating kan. So this is the first scenario lah, iaitu floating kan. Okay, so they ask you to determine the height of the block submerged in this water. Okay, like in the note, if you put your attention in the notes, so they give you, you can use this formula je untuk answer the question. Betul tak? Betul?
Oh, betul.
Kan? So you have let me go back. Okay, you have some part of the block is underneath, okay, the submerged block, and you have the total body lah of the block kan. So now you so you need to draw your FBD. Okay, now you have your W downwards, and you have your FB lah, upward kan. Okay. Okay, we don't have any force, external force kan, because it's floating. Okay, we don't need this in your FBD. You don't have any external force, whether it's acting downward or acting upward. So we don't need any force, external force to push the body or to push upward, because the body is floating. So the only component of force that has in this block is only the weight and also the buoyant force. Okay, so you can write your summation of force in vertical direction. So if you take upward is positive, so FB equal to minus W to 0 lah. That means your equation is FB equal to W, as easy as this. So when you try to solve this question, you know for the buoyant force, okay, you have your rho of the fluid, because this is force kat bawah ni lah, yang buoyant force ni yang bertindak ni. So the rho is the rho of the fluid lah, okay, times G times V kan, the V of this ni lah V of the submerged body kan, dan ni kan submerged je, okay. And so we call it displacement volume lah, VD, and equal to weight of the object. So you have your rho of your object, and you have your G constant, and you have your V of the object. Okay, now they ask you to find the H, this H. So you can translate this V in term of H lah. Okay, so you have your rho of fluid. Sorry, saya beli ni murah ya, sebab tu dia tak berapa lawa. So rho G ni F sini lah, sini. So rho of fluid G times A times HD kan. The area, the surface area sama kan, surface area sama, equal to rho of the object G A, the area of the surface area, times the total height kan, the HO lah. Ni HO berapa panjang ni, di bawah sampai ni HO lah. Okay, HO kan. Okay, now because of this sama value, you can cancel out lah. G, you can cancel out G, okay, and A, you can cancel out A kan. So now give you the rho of the fluid times the HD, the one that you want to find, equals to rho of the object H of the total object. Okay, this you can write in term of H lah. Okay, rho of the fluid is equal to apa? 1000 apa ni? 1000 tak keluar pula. Itulah ada air. Okay, 1000. Sorry. My pen is not working. Mana pen saya? Oh ni. Tak gerak pun. Alamak, sekejap saya guna mouse pula. Baru nak belagak ada pen. Okay, oh, okay. Rosak rosak lah. It's okay. 1000 I use a mouse conventional. So 1000 times HD apa? HD H lah So you want to find HD ni kan, displacement height. Okay, times H equal to the row of object. The block is 780. Okay, times the total object berapa? Apa nilai total object?
HD plus 0.2.
Okay, H lah So sama dengan H ni So H plus 0.2. So when you solve this question, it will give you H lah. Okay, so what is the value of H?
0.71.
0.71.
71.
Okay,
7071.
701.
Dia 0.709.
Oh, okay. So this solve your problem lah. So that's why I said it's very easy. Because floating only have buoyant force and weight of the object. Kan? Boleh faham kan? Boleh? Boleh? Alright, good. Well done. So now, so we solve this question. Okay, now another example. Anyone can want to try? Sebab pen saya dah rosak. Okay, anyone volunteer? Anyone? Come on.
Sama je sir. W minus buoyant force.
Sama je.
Sir.
Now the body is floating or submerged?
Submerged.
Submerged. So that means you have one more component kan?
Yes.
What is your component? Zid, betul tak? Sekarang ni beza tadi is floating. Alright, so you don't have any external force. Kan? So now your block is submerged in ada dua ni. Ada dua block yang berlainan. Satu oak, satu steel and is submerged in oil. Okay, now can you draw a FBD for this block, for this oak? What is the FBD? Your Fibonacci diagram. Tell me. Okay, apa? W kat mana?
W bawah,
W bawah.
Okay, W ke bawah. Okay, correct. Next.
B ke atas.
W ke atas, buoyant force. B. Lagi? Apa lagi?
Lepas tu determine the external force.
External force kan? But they ask you to determine the amount of external force for it to hold each block suspended in the fluid and the direction. So you have your another one which is the external force, and you
Force
not
dia ke atas.
you not sure yet. You not sure yet whether it's upward or downward, but you have this component lah. Okay, you have this component of external force. That's why they ask you to find the magnitude and direction. So they want to show whether it's upward or downward. Okay, now you solve for first question first. How you do it? Macam mana? First,
kita assume lah kalau apa ni ke bawah positif F1.
okay. So now first the summation of force in vertical is equal to 0.
Fy.
Okay. Now what's the equation?
Fe
Fe. So you assume downward positive Okay, Fe
plus W
plus W
tolak FB equals to 0.
equal to 0. Okay. Now your Fe equal to, because you want to find Fe kan?
FB minus W.
FB minus W. Okay. So that's fine. That's good. So how you can find your W and FB?
W rho GV.
W equal to rho GV. Okay. Rho of what?
Rho of O.
Okay. Please write so that you're not confused. So rho GV, V of the object jugalah. Okay. Write in your equation, right, so that when you want to put the numbers, you are not confused lah. Okay. The value for rho of the object is berapa?
858.38.
Oh, dah kira dah. Saya tulis ni 700 times 9.81 times
95
cube So what are the numbers?
.38
Newton
Newton.
Okay, so that's your W. So you need to find your FB. Berapa pula FB? Apa formula dia?
Rho GV
Row
juga.
of oil.
Rho of oil.
Okay, row of oil, the fluid tak O. Tak F lah supaya tak sama dengan yang O sini.
Oh, okay.
So row of the fluid times G times
V times
V. Apa? V apa?
The oil.
V of oak.
V of this block lah kan? It should be V of this displacement. Should be VD displacement V yang dalam ni kan sama kan, but it's similar to VO lah. V object kan, betul?
Oh, betul.
Okay, because when kalau awak buat yang floating tu remember if you put the yang floating, you remember this is VD kan, you just take this D kan, betul tak? So that's why when you do your submerge, you have to use the displacement volume, okay? But because of the displacement volume sama dengan the volume of the object, because it's totally immersed in the object in the fluid, so sama lah nilai dia, okay? So the rho of the fluid is equal to 850 kan? Ni kan?
Yes.
Times 9.81
9.8y
times
0.5
cube So this will equal to Oh, what's the number? What's the value?
One thousand and 42.3
1042.31 Newton Okay. So you have your FB, you have your W, so you can now find your FE lah. Berapa nilai FE? 1042.
weight minus FB.
Ni yang ni. FB minus W. Ni equation dia.
183.
Betul.
Berapa?
183.93 Newton.
183.93 Newton. So you have your magnitude. They ask you to find the amount of this external force, and the direction, and also the direction. So the first you said downward at the end. So maksudnya betul lah, sebab dia positif kan.
So dia bawah.
Bawah lah. So you don't have to change lah. Okay. Your first assumption is correct. So it mean apa, the external force equal to 183.93 Newton and acting downwards. Okay, now the second one. The second block is a steel block. How you can do it? Sama lah cara dia kan. Okay, guide me how?
Sama.
Okay, how?
Summation Fy equal to 0.
Draw your FBD first, right? Don't forget your FBD.
FBD.
So W goes down.
Going down.
And
going up.
FB go up. And your external force, what direction you want to assume? Upward or downward? Doesn't matter. Choose only one.
Going down.
Going down.
Down.
Okay, down. Okay, you assume down. Okay, doesn't matter. It's okay. Okay, now assume. Okay, now you write your equation. How?
Summation Fy equal to 0.
Fy equal to 0. Good.
Upward positive.
Upward positive. So
we got FB minus W minus FE.
B minus W minus FE equal to
0.
0. Okay.
Equal to 0.
Alright.
0.
Dah 0.
And then we going kita nak cari FE. So FE equals to FB minus W.
Okay, good. Now find your W and FB. Your W equal to
rho GV of steel block.
Rho of the block. Object.
S.
Okay.
Object.
Okay lah, steel. S. Okay, sorry. S. Okay, G and V of the object. Okay, the steel. Okay, the rho of the steel.
Steel.
Berapa nilai?
8050 times 9.81 times 0.5 to the power of 3.
0.5 power of 3. And the value is
9,871. 0.31
Newton
Newton.
Okay. Next. What's next?
FB. Find the FB.
Okay.
Rho GV of fluid.
Of rho of the fluid. Okay. Times G times V.
Sama dengan kau pernah tadi je.
Okay.
Times V of oil.
Okay. V of the displacement. VD sama-sama lah maksudnya sebab dia totally immersed kan.
Sama dengan tu.
Okay. So what's the value? Rho of the fluid is sama dengan ni lah sama dengan value ni kan.
Sama dengan tu.
Okay.
Yes.
1042. Okay, good. Okay, now you find your FE sama dengan Berapa your FD then?
Wait. 1042 tu minus dengan wait.
Okay, and then the value is
Sekejap.
FB 1042 minus 9861, which is negative lah. Negative apa?
If
871 madam. Madam pula sir. Sorry.
800.
Itu sir, sir.
Ah,
9871.
71. Okay, sorry. So berapa nilai dia FE minus
Negative 8829.
29. Okay. So what tells you?
So,
direction kita assume mula-mula tu terbalik. So
Salah.
means
ke
dia,
atas.
dia ke bawah.
Upward.
Okay, so your FE should
Okay.
go upward
Ah,
with the magnitude which is 8829. Okay? So salah lah tadi yang bawah tu, sebenarnya ke atas lah. Kan?
hmm.
So that's it lah. Itu je lah soalan dia. Itu je lah ni topik ni. Senang je kan? There's no any confusing component or anything. It's just component of your buoyant force and the weight and
Sir.
Apa?
Kiranya yang ni, kira yang stay block ni means dia ke downward kan?
Is it downward?
Sebab kan kita assume dia upward first.
Tadi awak assume awak ke bawah tadi?
Upward sebab dia punya FB positif.
Mana ni FB
Tadi
minus
saya
FB.
tadi assume downward.
Oh, ni
FB
salah ni.
Yang tu.
Betul lah.
Betul.
Betul lah tu.
Betul.
Sebab assume positif ke atas.
Ni betul lah. So maksudnya tadi
Kiranya sebab
dia
jawapan kita negatif, kiranya downward.
bukan.
Dia gerak ke atas.
Faham tak? Tadi siapa nama yang assume tadi?
Koyum.
Koyum. Tadi Koyum kata
Saya.
Koyum Tadi Koyum dia assume the external force is acting downward. So that's why the equation is FB minus W and W bawah minus FE equal to 0. Bila dia kira jawapan dia negatif.
Oh, kiranya dia upward lah.
Kiranya upward lah. Yang sebenarnya upward.
Alright.
If you assume at the beginning your external force is positive upward, bila you kira you should give you positive sini. So that means correct lah your assumption. Itu je. Faham?
Faham.
Okay, good.
Salah tadi.
So that itu je masalah dalam buoyancy ni, sama ada that object is floating. So when it's floating, so you don't have that external force, and you only have the buoyant force and the weight of the object. But in another condition, the object is immersed in a fluid. Okay, so that means you have another component of force, which is the external force, and this external force you're not sure whether it acting downwards or it acting upward. So you have to find the direction lah using the calculation. And itu je lah. The other thing tu benda yang hanya distraction je. You need to very careful with the numbers and the density of the object, the density of the fluid, and the dimension of the object. So that's only distraction. Benda yang sepatutnya tak menyusahkan pun lah. Betulnya kalau awak tulis equation tu betul-betul, and awak can just equate replace the value in your equation, and it will solve the question lah. You should find the answer. Okay. Alright. So we have another one. Last one. Now it's half past 1, so we have 20 minutes more. Okay, last one. Siapa nak buat pula?
Afan sir.
Afan? Siapa Afan?
Ketik sir. Ada.
Anyone lah, anyone. I don't like to petik nama anyone. I just want to.
Baik je.
But you petik you ni lah. Kalau orang tak salahkan siapa, salahkan awak lah, saya salahkan saya. Okay, siapa-siapa nak buat?
Syafiza, sir.
You should be straight away, straightforward. Should be easy. Siapa? Syafira?
Syafiza, sir.
Syafiza. Okay, Syafiza, siapa ada orang pilih awak? Bukan saya. Syafiza tak nak, tak apa, it's okay. Anyone? Any other one? Ha? Siapa? Sama je masalah dia ni, tak ada beza pun. Just the numbers and just the itulah, numbers lah yang berbeza. Okay.
Kejap so saya faham ke soalan.
Oh, okay. Siapa? Syafiza
So,
Baik, Syafiza.
Okay, good. Faham masalah? Okay, dah. Syafiza. Siapa tadi cakap saya tak sure siapa. Hello? Are you still there? Hello? Ha?
Sir?
Ha?
yang dalam meter ni kena tukar dalam meter dulu ke?
Of course.
Of course.
Of course you need to change it. Okay?
Kena so maksudnya yang 60 meter ni pun kena tukar dalam meter jugalah kan sir?
Betul. Anything that they give you, it should be convert in the standard unit lah. Because when you use the equation, rho GV or whatever, that equation is already in the standard unit so in meter, kilogram per meter cube. So anything numbers you should use the standard unit. So this one millimeter, so you should change to meter lah. Okay. Okay, macam mana? Don't worry about the numbers, just how we can do it by step. The numbers too we can put it after we have finished our equation. Okay, they have a cube. I help you to draw a cube first. In the meanwhile, you can understand the question. Okay, there's a cube. Okay, siapa? Syafiza. Dah boleh kan? Sama je macam tadi, macam kita buat yang lain tu. Sama je. Pastinya ada, mungkin ada sikit lah yang dia kita kena cari dulu. Okay. Dah. Ni first dia kata the cube.
Soalan ni saya jujur saya tak faham sir. Sebab dia ada specific gravity tu.
Specific gravity is SG kan? You know SG?
Dia kena darab 1000 lah nanti jadi density gas.
Betul. Specific gravity is just the numbers times row of water will give you the row of the glycerin kan? Betul tak?
Betul sir.
So specific gravity, the number if you times 1000, okay, you give you the row of the glycerin. So this is you can refer lah back to your equation kan, specific gravity, specific weight. Benda tu dia cuma just tukar-tukar je kan, tak ada ni pun. Okay, doesn't matter, we will help you Syafiza. Okay, draw your first FBD first. That one you ignore dulu. Jangan risau lagi. Put your FBD and equation first. Then we'll deal with the value later. Okay, your FBD first. So now dia kata a cube is made of rigid foam material and float in water in water with 60 mm of the cube below the surface. Okay, maksudnya dalam gambar rajah everyday water macam ni lah kan? Betul? Syafiza? Ke siapa tadi? Bukan Syafiza tadi
Ni dia macam sama dengan example 1 kan sir kan?
betul.
Sebab dia 80 meter and then 60 dekat bahagian bawah.
Betul. So this is
and then
your
20 kat bahagian atas.
Yes, correct. Okay, this is 20. Let's say in meter lah, so that's 0.02 kan?
Yeah, 0.02. And then bawah 0.06.
Okay, 06. Okay, good. So FBD ni W ke bawah macam mana? Your FBD, your free body diagram, your W goes mana? Upward, downward ke upward?
Downward.
Okay, your weight downward. Okay, and your FB upward kan? Are you following, Syafiza?
Summation FY equal to 0.
Okay, dah.
Lepas tu FB minus W.
Okay, FB minus W. Sorry, saya lambat sikit guna mouse ni. Okay. Okay.
So FB equal to W.
Good. Right. So what's your W? How you find your W? You cannot because they don't give you your V tak ada kan, row tak ada kan, just ni kan, tak ada row kan.
Tapi density
mana? Dekat mana? Density apa?
Density block. Apa ni fluid semata density cube tu.
Mana density cube? Kat mana tulis?
Dia tak bagi volume.
Tak ada, ni untuk water, ni glycerin kan?
Yang cube tu
tak payah buat apa pun kan?
Teka je saya teka-teka.
saya buat apa?
Saya tak payah buat apa pun sebab dia tak cari pun dia nak soalan dia yang ni sebenarnya. Soalan dia yang kalau dia the foam is completely submerged in glycerin. So this block submerged in glycerin. Okay, this is a row of glycerin. This is your free level water. Okay, now kat sini nak cari sebenarnya. So again, Syafiza, sorry. Your W, Syafiza, going downward kan? Okay, and you have your buoyant force FV. And what else you have? Your apa? Syafiza, ada ke tak ni? Internet awak ni ke internet saya yang tak ni?
Ada sir, ada.
Ada, okey.
So macam mana nak cari W sir? Saya tak tahu.
Itulah saya pun
Saya
tengah
tak
buat.
tahu. Sebab saya tak tahu yang mana nak masukkan.
Tak apa, it's okay. So I think W is equal to FB, betul? You dah betul dah sini. Tapi we have the FB, we have the specific gravity of this liquid kan. We can use FB sebenarnya, I think. So FB equal to apa? Tadi awak dah buat dia yang lain tu. FB equal to rho of the fluid kan,
Asal.
times G times V. Correct? Betul tak? Times V displacement kan. Faham tak ni? Macam dapat ni? Okay, now tadi awak dah buat your W equal to FB kan. So you know from the equation, from before we learn before, when it's floating, mana? Okay, when it's floating, the rho of the fluid, FB ni kat sini, rho of the fluid times G times the volume of the submerged body, okay, this VD, okay, is equal to W, and W is rho of this object times the G times the V of the object. Dapat dah sama ni kan? Betul? Ni equation ni. Okay? So that's how you can find the W using that. Faham tak?
Tapi soalan macam tak ada apa density rho untuk ni cube tu.
Ada ni. Density tak ada. Okay, density tak ada. Sabar lu. So now you now you said FB equal to W. Okay, betul? Kan? FB equal to W. Ni untuk floating ni, kan? So you can find your FB using the rho of your fluid, and rho of the fluid, they give you the rho of the fluid because they give you the specific gravity. Okay, so you have this rho of the fluid, and you have the G because it's constant, and you have the volume displacement bawah ni kan. Yang ni je. Because they give you the dimension, they said is 60 meter below the surface, so 0.06 times 0.008 times 0.008 because a cube, so it give you your VD lah, betul tak? Can you understand?
Saya tak faham sir.
Tak faham?
Sekali lagi sir tadi.
Okay, saya
sekali lagi sir.
Saya buang semua dulu ni. Sekejap Sekejap. Teruskan. Okay, we go back again from current slide. Okay. Apalah pen saya ni rosak waktu-waktu macam ni. Okay, pen. Okay. Dia kata the cube is floating kan. Okay, now the cube is floating. Okay. With 60 mm underneath. This is 0.06 and this is 0.02 lah, doesn't matter kalau 0.08 kan. And the dimension lain tu 0.08, ini pun 0.08 kan, the cube kan, macam tu Okay, this is floating. Remember the case when it's floating, refer back to your notes okay, here kan. So kat sini number 1, scenario 1, okay, the floating body, there are only two component kan. Ada FB dan ada W kan. FB equal to W lah, okay, FB equal to W kan. So FB, the buoyant force acting below ni, acting upward, is rho GV kan. And the rho is the rho of the fluid kan. The fluid ni yang kenakan daya kan. Fluid ni yang kenakan daya kat atas bola ni. Okay, the rho of the fluid times the G, constant G, and the volume submerged, volume yang submerged dalam air ni kan, yang ni je merah ni, yang solid ni okay, that's rho GV for FB, and this is equal to W, the weight of the object, okay, the rho of the object times G, constant G, times V of the object, of this object lah. So this V total ni V object lah. So this is the equation for floating body kan. So goes back to your problem tadi. Okay, now you have the object is floating with 0.06 millimeter underneath. So now they give you the row of the fluid. Okay, so you have this 1.26 kan. So Sg sama dengan kalau nak cari ke row, just times the row of water 1000, and we give you the row of the fluid, that fluid lah. Okay, 1.26 times 1000 will give you the row of the fluid, which is 1260 kilometer per meter cube, kilogram per meter pula. Okay, so you have your row, you have your G constant, and you have your V displacement, yang tenggelam tu kan, yang submerge. Okay, so this will give you the FB lah kan. You have your FB and equal to row of the fluid times G times V displacement, and this is equal to your weight kan. Betul tak?
Betul sir.
Okay, can follow until here?
Yes sir.
Boleh sir.
Boleh
Boleh.
So now you have all your value 1260 times 9.81 times V displacement. Tell me what V for this one, displacement. Apa nilai dia?
Sir, yang dia displace tu dia dalam water, dia bukan dalam glycerin kan?
Dalam
Water.
Okay, sorry. So you need to find this water lah. Sorry, not glycerin
Tapi kalau dia nak magnitude untuk completely submerge dalam glycerin kan, bukankah kita terus je cari 1260 times 9.81 times volume dia, terus dapat force untuk dia completely submerge.
Betul?
So saya dapat 6.32 kilonewton.
Awak dapat apa terus awak dapat apa?
6.32 kilonewton.
6.32 kilonewton. Mungkin betul lah, saya tak tahu. Tadi so volunteer tak nak volunteer. Okay, so how you do it?
Yang dia self explain tu dia dalam water.
Okay.
Sekarang dia nak nilai untuk completely submerge dalam glycerin. So kita terus je lah cari FB untuk glycerin.
Okay, good. So this is the glycerin sini glycerin. Okay, how you do it?
So 1.26 tu times 1000 dapat density untuk glycerin kan.
Alright.
Okay, 1260.
Okay, settle.
Okay. Formula dia rho GV, so times je dengan 9.81.
Sekejap, ni your FBD first so that people can follow.
W ke bawah, FB ke
atas.
Ke atas.
Okay, and then your FE, what assumption you assume? Bawah. Okay, this is your FE.
Yeah.
Okay, now you write your summation of force.
Summation of force Fy equals to 0.
Betul lah, 0. Okay,
So
good.
kita dapat FB minus W.
So you take upward positive end.
Minus W
minus
FE
equal to 0. Okay, so now your FE equal to
equals to FB plus W. W minus FB equals to FB minus W lah.
Okay. FB minus W. Okay, good. Don't mess up with this. Okay, now okay, you have this equation. So what's your W?
W kita untuk weight untuk dalam block water ke kat dalam glycerin?
Weight of the block. Tak kisahlah dalam glycerin ke dalam apa. So W ni refer to weight of the block lah kan? Okay, so what's your W for this block?
Saya dapat 3.76.
Okay, how you calculate this? How you calculate this? What's
1000?
Apa?
1000?
No, apa equation dia? Rho GV
Rho GV.
Okay, rho of the block lah. Okay, row of the block, row G, V.
Row G.
So what's the value for your row?
Row saya kalau guna W, saya ambil 1000.
1000. How you know?
Sekejap. Yang ni saya tak ambil pun W sebab
Kau tak
saya
ambil?
terus buat row GV 1260 times
120.
9.1 times volume.
That,
Volume dia 0.
that will give you FB.
FD.
And tadi awak apa yang awak kira FB, FB equal to row GV juga kan? Tapi row of the fluid lah. Okay, 1260 times G times the volume of this 0.
Volume dia
Volume
dia 0.8 times 0.8 times 0.8 lah sebab dia completely submerged.
Betul. That's your FB lah.
FD.
Okay, how you can find your W?
W tu ada kena mengena dengan displacement ke sir?
Displacement? Tak. No. I asking how you find this your value for W?
W.
In your calculation, you said you got 6.3 something eh?
Sebab FD tu 6.32 sir.
Okay, FB tu 6.2. So tak habis lagi lah. So you want to find FE kan?
FE. Saya rasa FE equals to FD.
Awak rasa apa?
FE equals to FD.
Mana boleh rasa? Mana boleh rasa macam tu? Okay, that's why they give you this, the floating ni, because when you want to find FE, you said FB minus W kan? And you need to find W. And they didn't give you the row of the object kan? So you cannot find the W without the row of the object.
Okay.
Betul? So that's why we solve this.
Oh, okay.
So when we have this value is equal to W.
Okay, faham.
And we can use that value in this equation.
Oh, okay.
Faham?
Okay, dapat dah. Okay.
Okay. So let's go back tadi, Syafiza tadi. Okay, Syafiza, back to you. Okay, now untuk yang floating ni, okay? So we can find the FB which is equivalent to W. Okay? Find the FB, this is in the water kan? Okay, salah bukan versi ni. So this is row of water. Because it's float in water Okay, 1000. Okay. Row of the fluid times G times the displacement volume VD is equal to W. The row of the fluid is 1000. Okay. Times G 9.81 times the displacement volume, which is what is it? Apa Syafiza volume dia yang displacement dalam ni yang kat bawah ni? Syafiza ada lagi ke?
2.88 kali 10 negatif 4.
Apa volume dia? Apa awak guna apa? 0.08?
2.88 kali 10 negatif 4.
Tak, apa dia punya ni? Apa darab apa?
0.08 darab 0.06 darab 0.06.
Okay, good. So that's the volume of displacement Kalau this kan yang bawah ni lah. Okay, 0.06 kalau dia cakap dia sama 0.06 darab 0.08 darab 0.08. Okay. So what's your value for FB? Bila awak darab semua ni, yang 1000 darab 9.81 darab yang volume ni, berapa nilai dia semua? FB.
$2.83
Newton
Newton.
Okay. If it's correct, then correct lah Maksudnya 1000 times G times V 2.83 Okay. Okay, this apa?
Saya dapat 3.767.
Oh. Syafiza, betul ke calculation awak? 1000 kali 1000 kali 9.81 kali 0.08 darab 0.06 darab 0.08. Salah
So yang 3 tu betul.
3 tu betul So Syafiza mungkin salah letak kot value So it's 3 point
Okay, sir.
7.
So 77. Okay. So 3.77 Newton. So this is your W. Kan? Because it's sama kan? FB equal to W kan? Okay. So when you get this value, now you can settle lah your question tadi tu yang dah buat tu. Siapa buat ni? Koyum yang buat Siapa? Siapa yang buat ni?
Aziz.
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 So, okay, Aziz, you already find your FB. You're using rho GV, the rho of the fluid times G times V, total volume of this object because fully immersed. So you get your value this and minus W and you get your FE. Di W sini lah 3.77. So what's your value for FE then? Berapa dapat?
2.56 kot sir.
Berapa?
2.56.
4.56.
2.56.
2.56.
2.56.
2.56 Newton. So, semua dapat sama FB minus W. Betul
Tahu.
I just trust your calculation lah. Okay. So your assumption tadi FE ke bawah ke atas? Bawah So that means correct lah. So the direction is downward and the magnitude is 2.56 Newton. Betul tak? Boleh? Okey ke ni? Susah ke? Hello?
Susah sikit sir.
Susah sikit sebab dia tak bagi
Susah
direct.
sikit sir.
Dia tak bagi direct macam soalan ni kan. Terus bagi your row everything. But in this case, that's why they give you this information The cube is floating. Okay? And you can find your W because they didn't give you the row of the cube pun. So you cannot find the row of the cube. But you can find it through the floating equation because it floats in the water. So the buoyant force is equal to W and the weight of the object. Okay, so whenever you got your W, then you can find you can answer the second the question lah. Okay, this one kan dia tak tanya pun, tapi sebab awak perlukan W ni, and that's why you find the W and you can replace it in the equation to answer the question lah. Okay, any question?
Sir.
Apa? Siapa tanya? Siapa nak tanya ni?
Kayu dulu.
Okay. Kayu, apa?
Tak sir, saya nak tanya tu yang 0.06 0.08 tu lah sir. Patutnya dia 0.8 to the power of 10 negative 4.
Kat mana ni awak cerita?
80 sebab 80 milimeter tu kan kita tukar jadi cm tu, so bahagi 100. So tukar lagi kepada meter, bahagi lagi 1000. So
bagi 1000 ke bagi lagi
so dia 0.0008
meter ke milimeter ke meter bagi 1000 kan? So 80 bagi 1000 je lah.
Milimeter ke meter bahagi
1000 lah, betul lah.
Bukan bahagi tu bukan sentimeter ke meter ke?
1 meter 100 cm. Betul?
Betul.
100 cm sama dengan 1000 milimeter. Betul?
Betul.
Okay, then so maksudnya 80 milimeter bahagi 1000 lah nak dapatkan in meter.
Bagi 1000 je Koyum.
Bagi 1000 je.
Oh ya ke? Okay.
Ni 1 meter 100 cm, 1 cm 10 milimeter. Ni apa?
Baik.
Ni conversion je lah don't apa ni mistake biasa lah, careless mistake. Just a conversion of apa millimeter in meter, just divide by 1000 lah kan.
Baik.
Okay. And tadi siapa tadi soalan tanya tadi?
Sir, yang FB dia kan row GV kan.
Okay.
Rho tu rho glycerin lah.
Ah. Row
Oh, okay, okay.
yang mana yang tu jawab ni yang bawah ni
Yang atas kanan.
Yang ni FB ni yang row
FB.
GV ni. Ini. Itulah. Row buoyant force.
Rho glycerin.
Row glycerin,
Kan?
yes.
Oh, okay, okay.
Kalau you
Thank you.
remember buoyant force ni ialah daya yang dikenakan oleh fluid tu kan. Kan dia kan acting downward ni kan. Dia acting daripada bawah ke atas kan. Betul tak? Okay. So daya ni daripada fluid lah. Daripada fluid ni kan. Kan dalam ni ada fluid kan. Banyak fluid semua benda kan. So we have to use the row of the fluid lah. So that's why you row of the fluid. So row of the whatever fluid lah. In this case glycerin. So this is row of the glycerin, which is 1260 times G and times V. So V is the volume yang displaced. Maksudnya yang dalam air tu, dalam fluid tersebut. So since it total submerged, so sama dengan volume of the object lah. Tapi kalau awak buat untuk yang floating ni, your V should be only yang tenggelam je lah. Bukan the total object. To find the FB. Faham
Faham, sir.
Faham. Okay, ada question lagi? Dah pukul 2 dah. Awak tak cakap pun. Kenapa awak tak stop saya? Patutnya 1.50 dah habis.
Tak apa sir, teruskan sir.
Tak, saya ada meeting ke mana ni. Okay. Okay, I think that's good. That means everyone's put attention. I like it. You just ask me any question. If I can answer, I can answer. If not, I will not answer lah. I will find the answer for you. So that's all for today. I apologize. I take your 10 minutes more extra from your time. Thank you. We'll see again tomorrow, insyaAllah. Okay, that's it. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Okay, thank you.
Thank you sir.
Have a nice meeting, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir.
Okay, welcome. Bye bye.
Thank you, sir.
Thank you, sir.
Baca lah, tak stop.